Hi, Chris Kuzmal here. Today we're going to talk about linear approximations of functions. Here we have an example function, this green line, which is actually the sine of x. And we have actually an approximation to the tangent, which is given by the line that passes through point A and point B. Point A and point B are at a sample point, and I can move that sample point around. So it moves along, sort of like a little skier going up and down the hill. The skis kind of shift position. And we can also vary how far away those 2 points are. And that sort of, in a vague sense, corresponds to how long my skis are. And of course, my skis have to kind of plow through the hill here. And in any case, those my skis sort of give me an approximation of the function, local, near to the function. That's the case. And indeed, as the distance between A and B shrinks, as that approaches zero, that line becomes the definition of the tangent line. And from it, and so the question is, how can we derive the actual function for that tangent line? Well, let's first of all look at the actual tangent line. Tangent line is actually passing through there. It's the blue line. So we can set aside our approximate line and say this blue line is the exact tangent at point A. Okay, so let's get rid of point B. So that's the exact value of it. But what is the formula for that? The formula for that comes from the point slope formula. We know what the slope is. It's the derivative of the function at that location, at that sample point. We know the point is the intersection of the vertical line of the sample point and the function. So if you plug those two things in, you'll get this formula down here in the lower left-hand corner. P of x equals f of the sample plus f prime of the sample times x minus the sample. Often the word sample is replaced with a variable name like c or a, which makes for a terser, more pithy description, but it's a little less clear what we're talking about. I think we use the word sample to represent the point of the function at which we're doing our approximation. That's what this blue line is. And we'll zoom in on this function just so you can see it more clearly. Right here is p of x. Okay, and that's linear approximation.